Hi everyone, in this video we look at how to simplify radicals into mixed radicals. So in this example it says write the following as mixed radicals. So we have the square root of 50. So if we want to write the square root of 50 in terms of a mixed radical, first I need to figure out what perfect squares go into 50. So an easy way to do this is to prime factor 50. I can rewrite 50, well that's equal to 2 times 5 squared. So 50 prime factors into 2 times 5 squared. So I know that 5 squared is a perfect square. So I can rewrite the square root of 50 as the square root of 2 times 5 squared, which is 25. Now remember what we looked at in the last video. We looked at this identity that the square root of a times b is equal to the square root of a times the square root of b. So let's rewrite this. Let's rewrite this as the square root of 25 times the square root of 2 using this identity that we've developed. Well, the square root of 25 is 5. And the square root of 2 we can't simplify any further. So the square root of 50 simplifies to 5 times the square root of 2. Now, you might be able to do this in your head, but you should show your work when you're simplifying radicals. In the next example, we have the square root of 98. So let's rewrite this and let's try to figure out what perfect squares go into 98. Well, 98, if we prime factor it, this is equal to 49 times 2. 49 can be rewritten as 7 squared. So 98 is equal to 2 times 7 squared. So I can rewrite this as the square root of 2 times 49, which is equal to the square root of 2 times the square root of 49. And the square root of 49 is just 7. So I'll rewrite this as 7 root 2. And this is in mixed radical form. This is a mixed radical. Next we have the cube root of 56. So the same rule applies for any root in that I can if I want to do the cube root of AB, well that's equal to the cube root of A times the cube root of B. So let's go ahead and apply that principle here. First, let's figure out what perfect cubes go into 56. So let's prime factor 56. So 56 I know is equal to 7 times 8. And 8 can be rewritten as 2 to the power of 3. So 8 is actually a perfect cube. So I can rewrite this as the cube root of 7 times 8, and again 8 is a perfect cube, which is equal to the cube root of 7 times the cube root of 8. The cube root of 8 is just 2, so I can rewrite this as 2 cube root 7. Next, let's do this one. This one looks intimidating. We have the cube root of a to the power of 5, b to the power of 9, c to the power of 11. So although this might look more difficult, I already have a to the power. I already have all of my variables in terms of their power. So I know how many factors of each variable there are, which actually makes my life a little bit easier, because sometimes if you have these numbers and they're a really big number, they're difficult to factor. It's really difficult at times to prime factor really, really big numbers. So let's go ahead and we'll try this out. So I can rewrite this as a to the power of 3 times a squared, because when I multiply two bases that are the same, I can add their exponents. So a to the power of 3 times a to the power of 2 is a to the power of 5. And I'll keep this as b to the power of 9. You'll see why I'm doing this in a second. And then I've got times c to the power of 9 times c to the power of 2. And again, c to the power of 9 times c to the power of 2 is c to the power of 9 plus 2, which is 11. So I've got the cube root of all this. This is equal to, well, let's think about this. I can rewrite this as the cube root of a cubed b to the power of 9 times c to the power of 9 times the cube root of a squared c squared. Okay, so why is that helpful? Well, now I have the cube root of a to the power of 3 times b to the power of 9 times c to the power of 9. So let's think about what the cube root of a cubed would be. Well, the cube root of a cubed is just a. Let's think about now what the cube root of b to the power of 9 would be. Well, what number, if we look at b cubed times b cubed times b cubed, well, that's equal to b to the power of 9. So the cube root of b to the power of 9 is just b cubed. Since the cube root of b to the power of 9 is b cubed, then the cube root of c to the power of 9 is c cubed as well. So this simplifies to a times b cubed times c cubed times the cube root of a squared times c squared. So that one was a little bit tricky. Next, let's look at simplifying two radicals involving a ratio. So if I have the square root of 18 over the square root of 63, the first thing that I'm going to do is I'm going to simplify the radicals. So the square root of 18 can be written as the square root of 9 times the square root of 2. The square root of 63 can be written as the square root of 9 times the square root of 7. Because 9 times 7 is 63. 9 times 2 is 18. Well, now we can see the square root of 9 is just 3. Divided by the square root of 9 is, which is 3 as well. These square root 9s divide out. So I can divide out the square root of 9. And I'm left with just root 2 over root 7. Now, since it's very difficult to add or subtract, or since I guess it's more difficult to add and subtract numbers with radicals in the denominator, we'll say to always rationalize the denominator. The denominator. So what does that mean? Well, it means that we're going to try to get an integer in the denominator. Now, you might have some trouble thinking about how to do this, but there's a really easy way. You just multiply the numerator by the square root of 7, and you multiply the denominator by the square root of 7 as well. So all that I've done is I've multiplied this fraction by 1, and if I multiply the square root of 7 times the square root of 7, I will get 7, because the square root of 7 times the square root of 7 is just 7. Root 2 times root 7 is just root 14. So this simplifies to root 14 over 7. Always rationalize the denominator. That concludes this part of the lesson, and we'll see you in the next video.